All right, so here's example 11 from the lecture notes. Okay, first thing, notice that they're not using joules. This problem is using watts, which is no big deal because what's a watt? A watt is what? It's a joule per second. All it is joules per second. What is mega? Mega is 10 to the 6. It's a million. Mega's a million. So we have 120 megawatts. That's the power output. So look, the diagram for our heat engine. In the lecture, I explained everything in terms of joules. You know, like Q right here. What is Q? Q is heat. What do we measure heat in? Joules. We had joules coming in. We had joules coming out as work. Work is measured in joules. And then heat gets dumped to the cold. That's joules. Now look, in this problem here, we're not using joules, we're using watts, which is power. Power is watts. You know, the basic definition for power, you could say that power is work per time, or you could say power is energy per time. And heat is a form of energy, you know, so you could say Q over T. That'd be power. All right, so on this diagram, just so it makes sense, let's erase the Q's and the W. So we're not expressing things in terms of joules. So I'm going to take that away. Take that away. We're talking in terms of power. So this is going to be power from the hot, PH, power from the hot. This will be power output of the engine, and then this will be power to the cold. All right, what they give us in the problem is the power output is 120 megawatts. Okay? And then we're also told that the efficiency of the engine is 40%, which in decimal form is 0.4. So questions A and C we can solve very, very quickly. So the definition for efficiency, so efficiency using power hot, power output, and power cold. What would efficiency be? It would be the power output divided by power from the hot. That would be our equation for efficiency. We know the efficiency and we know the power output. So what's power from the hot going to be? It's going to be the power output divided by the efficiency. So the power output is 120 megawatts. The efficiency is 0.4. So this is 300 megawatts. Power, and that's the answer to A. A is 300 megawatts. So if the power from the hot is 300 megawatts, what must be the power dumped to the cold? It's got to be 180. Right? Because if 300 comes in, 120 comes out as work, then the other 180 has to be dumped, right? This must equal these two added together. Okay? So we've answered A and C. Now, how do you do part B? Well, let's leave this. This is megawatt. So how do you do part B? So part B, here's what they're telling us. The heat of combustion of oil is 4.4 times 10 to the 7 joules per kilogram. Determine the rate in kilograms per second at which oil is burned. Where is the oil being burned? Is the oil being burned down here in the cold reservoir? No. Is the oil being burned inside the engine itself? No. It's being burned where the heat is being generated. Where is the heat being generated? Up here in the hot, right? So they're giving us two pieces of they're giving us a piece of information about the hot reservoir. We're being told that we get 4.4 times 10 to the 7th joules per kilogram of oil. Can you guys visualize that? It's like, look, here's a little box, right? This little box right here represents 1 kilogram of oil. How much energy can you get from that 1 kilogram of oil? 4.4 times 10 to the 7 joules. Okay? What they want us to figure out is how quickly is the oil being burned in kilograms per second. We want the answer over here to come out in kilograms per second. We'll take a look at the info they gave us. 4.4 times 10 to the 7 joules per kilogram. Where does kilogram need to end up? Does kilogram need to end up in the numerator or denominator? It needs to end up in the numerator, right? Because we want kilograms per second. So we're going to have to do what to this value? What do we have to do to this value here? Flip it. We're going to have to flip it. Now, what's the other thing we know about the hot reservoir? There's something else we know about the hot reservoir. How much energy is coming out of the hot reservoir? 300 megawatts. What is mega? Mega is 10 to the 6. So what's 300 mega? 300 mega would be 3 times 10 to the 8th, and then what's a watt? Joule per second. Okay, so these are the two things that we know about the hot reservoir. Okay, if we multiply them together right now, if we multiply these two values together, are we going to get our answer? Nope. But look, if we flip this first value, I'm just going to erase this. I'm going to just flip it around. Put kilogram up top. 4.4 times 10 to the 7 joules on the bottom. What cancels now? If we multiply these two values together, what cancels? The joules cancel, and notice what we're left with. Kilogram per second. 6.8 kilogram per second. So basically, how do you do part B? Part B is a unit analysis, dimensional analysis. You figure it out by looking at the units that you have. Okay? All right, part D. Now, guys, this year I haven't taught chapter 11 yet. To do part D, you really need to know chapter 11, which is something you should have learned in chemistry. So would I put this on the final exam? No, for that reason. But how would you do part D? Part D, there's an equation. What's the equation? Q equals M. In chemistry, I think it was MS delta T, where S is specific heat. In physics, it's MC delta T. Okay, so what is Q? Q is the what? Heat energy. M is the mass. C is specific heat. And then change of temperature. So we're asked to solve for change of temperature. Change of temperature is going to be Q over MC. What they're saying is they're giving us the cold reservoir. The cold reservoir is this full tank of water. So you got to find the volume of the water. The volume of the water, when you multiply those dimensions, it comes out as 10 to the 5th cubic meters. Now, from that, can you find the mass of the water? Using the density equation. What's density? Density is mass over volume, so mass is density times volume. The density of water is right here, so the mass of this water is 10 to the 8th kilograms. That's our M. Mass is 10 to the 8th. Now how do you get Q? Look at heat energy is being dumped into the water. What do we know about that? Well, power to the cold is 180 megawatts, which is 1.8 times 10 to the 8th joules per second. That's what 180 megawatts is. How much time is it being dumped to the water? For an hour. So you got to multiply this. You got to multiply this by an hour to get the Q. And the Q is where did I write it? 6.5 times 10 to the 11th.